59 and 60. Okay, so we're on 3.4. Is that right?
Don't forget 40. 40.
So 40, right? Okay, 40 says h of x equals 4 over x. And it says, graph each function using the techniques of stretching, shifting, reflecting. Start with the basic graph and show all the stages. So this is like, okay, everybody watch please, because people struggle with this because these are fractions. Okay, this is like 1 over x. It's like the reciprocal function, except for, how did they get the 4 up there? They just multiplied it by 4. That's it. Okay? So this is the same as 4 times 1 over x. Because you could put that over a 1, multiply straight across, you get 4 over x. So if we had this one, everyone in here would know what to do with that one. What does the 4 do to the parabola? Okay, makes the points 4 times as tall. It's a vertical stretch and all that sort of stuff. So the same thing happens here. So if we think about what it normally looks like, okay, it normally looks like this guy right here. Okay, something like that. Okay, but we're going to make this, okay, that point right there is 1, 1, right? We're going to go over 1. Instead of going up 1, we're going to go up 4. Okay, we'd normally go over 2 and up a half. We're going to go over 2 and up 4 times as far. So 4 times a half is 2. So what it does is, it vertically stretches this. It makes it taller than it used to be. Doesn't change the shape that much. Okay, I mean, it still looks basically the same. It's going to look something like that. I would label at least 2 points on that. If this one is 1, 4, what's this one right here? -1, -4, because this is still, what type of function is symmetric with the origin? An odd function is symmetric with the origin. Okay? All right, any questions there? Okay, and then what were the other ones? 59 and 60. Okay, so we'll take a look at this one. Here's number 59. Tell you what, I'll do 60. Okay, so this is this is not so much about getting every single problem right as it is about understanding what's going on. So I want you to watch and make sure you know how to do this. So this goes from here to here to here up to 2, 2. So it goes to there. And then it comes down here to, this is 4, -2. So about to right there. So the graph looks something like this. This, and this. Any questions there? That's what it looks like, right? I'm not going to do all of these, but I'll pick a couple and we'll do these in different stages. So let's say I do, let's see, I'll talk about this one right here. Let's say A is, big F of x is little f of x plus 3. Okay, what happens when you know what shape a function makes and then you add 3 to it? What does it do to the graph? Moves it up 3. Easy enough? Okay. Let's see. B is f of x, or they called it a g of x, equals f of x plus 2. What happens if you know what shape f makes, but you do x plus 2 in parentheses? What does that do to the graph? Moves it to the left 2, right? Okay, which ones are the more complicated ones? C? Okay, all right, we'll do C. C says p of x equals negative f of x. What happens if you know what a function looks like and then you multiply it by a negative? For example, what happens if you know what x squared looks like and you put a negative in front of it? Flips it upside down. It is a vertical flip. So what it would look like is we'd take this graph and we'd say, okay, this one's going to come up here, that one's going to come up here, that's going to stay right where it is, that's going to come down here, and this is going to come here. So it does this, this, and this. Okay? Okay, what's another tough one? Well, wait a minute, that's not very tough, is it? Once you get how to relate it to what you already know how to do. Okay. Okay, let's look at f. F is this. It says little g of x equals f of negative x. Okay, now if we know what the function is and then we multiply it by a negative, so if we know what shape it makes, then we multiply it by a negative, it is a vertical flip. It changes the y coordinates. Remember, f of x is the same as y, so it's like multiplying the y's by a negative. Okay, here we've got a negative, but we're multiplying the x by a negative. If this is a vertical flip, because we're changing the y, here we're changing the x, so it's a horizontal flip. So it would look like this. This point would come over here, this point would come over here, this point would stay right where it is, this one would go over here, and this one would come over here. So it looks like this. Okay. Can you see how the blue one, all right, that's not perfect, but can you see how the blue one and the black one are kind of reflections of each other? Horizontal reflections. Okay, horizontal flips. Okay, do one more. G. Okay, so G says this. Let me change colors, make this really apparent. Okay, so here's G. G says h of x is equal to f of 2 times x. Okay, now, we're multiplying the x by a number before we even make the shape. So is this going to be a horizontal change or a vertical change? How many say horizontal? How many say vertical? Okay, there were a couple people voted for each. More votes for vertical. Guess what the vertical people are? Wrong. Okay. Okay. Just like this, take a look here. This was a vertical flip. This was a horizontal flip. Notice I'm changing the x's here. So this is a horizontal stretch or shrink. You would think that multiplying by 2 would horizontally stretch it out. Okay, but remember what I said about changes in the x direction and the horizontal direction? What do? The opposite of what you'd think. So it's not going to horizontally stretch it out, it's going to horizontally shrink it. So I'm going to take this and I'm going to shrink it back toward the origin. I'm going to take the x coordinate and divide it by 2, not multiply it by 2. So that's going to move this one here. That's going to move this one here. This one stays right where it is because the x coordinate is 0 and 0 divided by 2 would still be 0. This x coordinate is 2, so I slide that halfway back to the the y-axis. Slide this one halfway back, and it looks like this. Okay? Can you see how the green one is like a horizontal shrink? It's like these points have been taken and slid back here. These ones have been taken and slid back here. Can you see that? Okay, that's what happens there. Okay, I agree those are tough, but they're really good for understanding how these transformations work on any type of function. They didn't even give you a rule, all they gave you was a picture. Okay? And yeah, if you were going to make it look right, you might have to graph that 2 or 3 times or slap that on a copier, copy it off. Okay? Yeah.
What it was for me is I just didn't really understand what it wanted me to do when I looked at it.
But it's easy now?
Yeah, I
Okay.
understand now, but when in the book it wasn't very.
Okay, let me show you, let's see, so here's 3.4. Here's where we went over this. Okay, okay, I spend a lot of time putting these notes together and a lot of time thinking about how I can make this easier for people to understand. So this is what I want you to spot. Notice that when we wrote these, this is exactly how that's written on those problems. Okay, we did a problem just a minute ago that was, it said f of x plus 2 or something like that. Okay. If you know what the shape is, if you know what the function is, if you add or subtract something, you know you take that exact same shape, slide it up or down. Same thing here. If you know what the shape is, and inside parentheses you're adding or subtracting something, you know you're going to slide it left or right. Okay, so that's the notation. I tried to use that exact same notation here. If any of you, well, you all took 1010 here, I believe. If you go back and look at your notes in chapter 8 for the 1010 class, this doesn't have f of x here, it has x squared there. Because in that class, all we dealt with was that nice familiar parabola. Okay, and now we're kind of increasing our capacity a little bit here, using different types of functions. Okay, and if you know what it does for x squared, the point here is just take that shape, whatever the shape is, Slide it up or down, slide it right or left, and look at these rules here. If you multiply it by a negative, there's a vertical flip. That is exactly how that previous problem was written. That's exactly how problem number, part C for those problems is written. Okay? So those are the things I want you to pick up on. All right? Okay. Any questions? What's that?
Can we work on this one for a second now that we know how to do it?
How about we correct it tomorrow? Does that sound good? Okay. Let's correct 3.4 tomorrow. Okay? I won't do that all the time, but again, this is an important thing to understand. Okay? If you know what the shape does, if you know what shape it makes, or what the function does and what shape it makes, okay, these rules apply no matter how ugly it is. We dealt with the squaring function on all of these. Okay? And then we even showed this right here. Okay, so remember on the problem that we just did, we just had f of, 2x. Okay, they just put a 2 there rather than an a, and it says if a is greater than 1, it's shrunk, it's horizontally shrunk. If a is between 0 and 1, then it's horizontally stretched. So if this had been f of 1/2, or let's do 1/3 x, it would have taken that shape that we had before, that shape that looked like this, and it would have stretched it out by a factor of 3. So if it normally went, listen up, if it normally went from -4 to +4, if we stretched that by a factor of 3, it would have started way out at -12 and ended at +12. But it wouldn't have changed these y values. It would have just done something like this. Okay? Would have stretched this way out here, done like that, and then like that. Okay? All right. Okay. So go ahead, you can go ahead and put that away. And instead, we're going to do some really fun stuff today. It's on mathematical modeling, which is a fancy way to say we're going to do a bunch of story problems.
Oh.
There we go. That's the desired effect. Should hear an audible, oh, we hate that. I heard that sucks. That's nice. Also what we're looking for. Yes, it was my birthday yesterday. Which I will happily tell you now that it's not my birthday.
Well, we should sing you a happy late birthday.
No, because there's no song for that. I'm 41, so. Yeah? 41. Yep. Born in 1971. Can you believe that?
You're a hippie dude.
No, I'm after the hippies. Yeah. Okay. Nope. Yep. 41. That's the way it goes. Okay. This is a pretty extensive starter question. Questions. There's a whole bunch of them there. Okay. I want you to just look at that for a second. If you absolutely for sure know the right answer to those, you can go ahead and write them down. If you're not sure, okay, we're going to make sure you're sure in just a minute. Okay. So go ahead and scan through there. If you know what the answers are, write them down. Still working on 3-4. Okay, just lend an ear while you're writing a couple of those things down. I do this for a reason, and I'm convinced that most people could solve story problems and they could at least set them up and get started and get to a point where they could actually finish it off. If they just calmed down and thought about what's all the stuff that I already know, okay? How could I make this, look a little bit simpler than this overwhelming paragraph that has all of this funky stuff in it? Okay? Because a lot of this stuff you're aware of, or you could find pretty quickly. Okay? If you don't know what some of these formulas are, you could look them up in the back of the book. There's an appendix and formulas inside the front cover and the back cover and different things like that. So on most of these problems, what we're going to do is we're going to look at it. We might draw some pictures, and we might talk about, well, what's going on here? Okay, if we were going to find an area, how would you find the area of this particular shape? If it's a square, a rectangle, a circle, or something like that. Okay, if we're talking about how fast something is going and how far it went, okay, and how long it took to go that far, there's a formula that you all know that you're familiar with, that we could at least say, well, at least this is a starting point. Okay, might I use this equation or something like that? Okay, so let's start with this one right here. What is the formula that relates distance, rate, and time? D equals RT. So the distance equals the rate times the time. So if I'm going 50 miles per hour for 2 hours, you know for a fact I traveled 100 miles. Okay, just a simple multiplication problem. And you can take this and you can solve it for any one you want. So if I wanted to say, well, I want to know what the time is. Take the distance divided by the rate. I want to know what the rate is. Take the distance and divide it by the time. So we can manipulate that very simply, okay, algebraically manipulate that so that we could solve for any variable that we want. Okay, now that's not hard, is it? Does anybody have any questions about that? Okay, formula for the area of a rectangle. Okay, length times width. Base times height, if you were taught it using that vocabulary. Either one of those is fine. Okay, same thing there. For a triangle, most people aren't taught 1/2 length times width. They're taught 1/2 base times height. Okay, and so these have to be perpendicular to each other. It has to be how far it is from the bottom up to the top peak there. Okay, and formula for the area of a circle. Now don't say anything out loud. Okay, this is one where a lot of people get a little bit confused, because they think, I know a couple formulas. I know 2 pi r and I know pi r squared. And what makes these both confusing is they both have a pi, they both have an r, and they both have a 2. They're just in different places, right? Okay, well, if we were talking about area, okay, the unit for area is like square feet, square meters, square inches, square yards, stuff like that. So if you know the unit, that might help you figure out which one of these is the correct formula. So if area is in square units, it's got to be this one right here. So this is going to be pi r squared. The one with a square, that's the formula for area. Okay, now what is this one right here? That's circumference. Okay, that might be a good one to keep track of. Okay, what's the Pythagorean theorem? A squared plus b squared equals c squared. Okay, heard that somewhere. It's important to remember that the A and the B, those are the legs of the right triangle, and this only works on a right triangle. So those are the legs of a right triangle, and C is the hypotenuse. What's the area of this rectangle? Yeah, it's just xy, that's it. Just base times height, length times width. Okay, what's the formula for the area of this triangle? And we'll assume that that's a right angle right there. Okay, so this would be 1/2 xy, or you could do xy over 2, that would be fine. Okay, I'm going to write the area equals this and the area equals this. Okay, because normally we like to say, well, it's like a function or something like that. Okay, and what's the formula for the distance between 2 points? We've talked about that before. So that's a d equals big long square root, and it starts with, okay, we usually do the x's first, but it doesn't matter. Okay, I'm just going to do x2 minus x1, difference between the x's quantity squared, y2 minus y1 quantity squared. Okay. And so let's go ahead and do this one right here. Okay, easy problem. This is going to be our x1 and our y1. This is going to be our x2 and our y2. So the distance between the two of those is, this is going to be 4 minus 0. Remember, write down what the x2 is, write the minus, and then go look at what x1 is, because the minus is part of the formula. We'll square that. And then this is going to be 3 minus, go find the y coordinate for the first one, square that. So this is going to be the square root of 4 squared plus 3 squared. That's the square root of 16 plus 9. Square root of 25 is 5. So that's the answer. Okay, now, before we do the last one, okay, you don't even need to look at the last one yet. Are there any questions on anything we've done so far? None? Okay, let's take a look at this one then. What's the difference between this problem I just did and this guy right here? Yeah, this second one has variables in it. It doesn't have numbers in it. But that's not a problem if we think about it the same way. Well, this was x1, y1. This is x2, y2. So I'm going to do d equals a big square root, and this is going to be x minus 0 quantity squared, y minus 0 quantity squared. And then I just simplify, just like I did here. I can't simplify as much because I've got variables in there, but I can still get it to this point right here. I can say d equals the square root of x squared plus y squared. Okay? Any questions? Is this easy? If the whole assignment were like this, Shane, you'd be in good shape? You wouldn't go to sleep on me? Okay, that's what I like. Okay, so this section is about applying stuff like that in real situations. And some of these are kind of made up. I mean, how often do we look at a graph and say, hey, you know, I'd like to put a rectangle underneath that parabola. That would really make my day. Okay, but there are some problems in here. We use these to kind of figure out, okay, we're familiar with the math here. Okay, let's throw a geometric shape in there. And then later on, we'll do some problems where it's a little bit more real world. Okay, so this one says area of a rectangle. A rectangle has one corner in quadrant 1 on the graph of 25 minus x squared. So they've given us a picture of what this looks like, but this is a parabola that opens down and has been slid up 25 units. So we would normally think of it this way. Okay, that might look a little more familiar if they didn't give us a graph. Okay, so there's what the graph looks like. Notice it crosses right here. The vertex would be at 0, 25. Okay, another vertex at the origin, and a third on the positive y-axis, and a fourth on the positive x-axis. So all of this to right here. Okay, everything on that line and this line all the way to right there. All it is just describing that picture right there. It's just setting it up. We've got a rectangle. It's got a vertex here, 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 and here. Here's the one at the origin. Here's the one on the y-axis. Here's the one on the x. And here's the one that is right on that curve. Okay? Any questions? Okay. All right. So here's what we want to do. We want to figure out what's the area of that rectangle. What is the area of that rectangle? Well, this point right here is just on here. We don't know what it is. Okay? It's just the point xy. So this point right here, it looks like it's 3, but it's not right on 3. Okay? And since it's a variable, it could slide anywhere from here to here. It could start down here at 0. It could go all the way up to right here, the x-intercept for that parabola. It could go up to 5. Anywhere in between would be okay. The point here is if this is x, this point is x comma 0. If this is y, what's this point over here? 0 comma y. Okay? Is everybody okay with that? Okay, so we've got the 4 coordinates marked off. Or sorry, the 4 corners. 0, 0. This is x0. This is 0y, and this is xy. Okay. Easy enough? Okay, there's the rectangle. My question for you is this, okay, and I really think this is all it takes. Can you tell me how long this side is right here? How far is it from here over to here? It's from 0 to x, right? Well, if you go from 0 to x, if you went from 0 to 1, you'd say the answer is 1. If you went from 0 to 2, you'd say the answer is 2. If I went from 0 to 4.8, how far is it from 0 to 4.8? 4.8. So how far is it from 0 to x? It's x. How tall is it? It's y. Have we seen this problem before? Absolutely. It's this right there. Looks a little bit different, but it's the same thing. It's a rectangle. The base is x. The height is y. So that means the area is x times, whoops, just x times y. Is that all right? Okay, here's the problem. Do we normally like to have more than one variable over on this side? If we're dealing with a function, we normally don't like that, right? Okay, so in this problem, could we change this somehow so that we only have x's over here instead of an x and a y? So we're only working with one variable rather than two. Well, on this problem, what does y equal? It equals 25 minus x squared. So this means wherever there's a y, I can put a 25 minus x squared. So this would be x times 25 minus x squared. Okay, now watch. I'm going to do one other thing. Okay, I'm going to make this look like function notation by saying the area is a function of x. So you tell me where we are on the x-axis, and I'll tell you just by plugging in here what the area of our rectangle is. Does that make sense? Okay, that's all I want you to do on that one. Any questions? Does this actually work? It does. Now, if I put x right here, how wide would the rectangle be? Okay, if I stayed right here at the origin, would it have a width? Would it have a base? No, but it would be 5 units tall, right? So no width, 5 units tall. Base is 0, height is 5. What's the answer? Answer is 0. So if I plug in a 0 here, so if I find a of 0, that would be 0, 25 minus 0 squared. 0 times 25 minus 0, that is 0. Okay? Same thing would happen here. What if I made it all the way out to here? So if I plugged in a 5, what should a of 5 be? So if I had the base went all the way out to 5, there's no height there, so it should still be 0, right? So this would be 5. This would be 25 minus 5 squared. That's going to be 0. So I have 5 times 0, answer is 0. Now, in between, we'll get a nice positive number. Okay, but that's how we'd find that one. Okay, that's it. Some of them are just write down an expression. Okay, but again, we want to use one variable. Any questions there? Okay, enough yakking about that problem. Let's flip the page over and let's look at this one. Okay, this one's a little different, a little more extensive. Okay, this is what you're going to typically see on the problems from the assignment. This one says a rectangle is inscribed in a semicircle of radius 2. See the figure. So on some of them, they've done you the favor of actually drawing a picture. Here's another one where the picture's already drawn. And they gave you an equation for the top half of a circle. Okay, so that's good. It says let P equal xy, so we've got a point on the circle, okay, and we're just calling it xy like we did before, okay. Be a point in quadrant 1 that is a vertex of the rectangle that is on the circle. And then it says this, express the area of the rectangle as a function of x. That sentence right there basically says do exactly what we did on this problem right here. Come up with an area function that only has x's in it, not x's and y's. Okay, but here's what I'd like you to do. I'd like you to look at this and say, well, these points here, so if I slide this one over, that one slides over, okay, and the height comes down. If I slide this one in, that one slides in, and I'd get something that might look like this, right? So if this point is x, what's the x coordinate of that point right there? X coordinate. It would be x, the y coordinate would be 0, right? This is symmetric, so this point here would be negative x comma y, or sorry, negative x comma 0. Okay, and that's actually enough right there. So I'm going to draw the rectangle like this. And my question for you is, how far is it from here to here? And how tall is it? So if I went x over here and I went x over here, isn't this little distance right here x? And isn't this little distance right here x? Does that make sense? So Charles, what's the answer? Okay, this is 2x. Okay, if this is y right here, okay, just like the one that we did a second ago, Remember how that one was y units tall? That point is xy, so it's x wide and y tall. Okay, this is like having two of those. This would be x wide and y tall. So the whole thing is 2x wide and y tall. Shane, we doing okay? Excellent. Any questions? So ignore the rest of the problem, cover it up if you need to, so you can't even see it, and let's just stare at this for a second. And the problem says, express the area. If you were going to look at that, if somebody walked in here, they didn't even read the question and they just looked at this and we said, hey, what's the area of that rectangle? They'd say the area is 2x times y. Okay? Now we're a little more sophisticated than that, so we're going to look at this and we're going to say, hey, there's something I don't like about this. I don't like working with two variables. I want to have just an x. So in this problem right here, this is the key, it says what y equals. What does y equal? Square root of 4 minus x squared. So I can write 2x, and in place of the y, I'm going to write 4 minus x squared. And then I'm going to change this a from just a plain old a to a of x. Because now this will tell me what the area is if I just plug in an x. I don't need to worry about finding y or anything like that. This does it for us. That is the answer to the first question. Now once you have that, the rest of the problems is relatively easy. Okay? Any questions? Yeah. Okay, because on this side we go over x, and on this side we go over x. So it's kind of like having, remember the problems on the previous page? That would be x, and this would be y, this would be x, and this would be y. So if we said, how far is it from this corner to this corner? You'd have x here and x here, so you'd have 2x altogether. And how tall is it? Well, it's y on either side, so it's just y units tall. Emily?
So if it was right in the middle of the graph, it would be 2x on the bottom and 2y, because say like the origin was right in the middle of the rectangle. You put the 2x there because it's in two different quadrants, right?
Let's see. Okay. So on this previous one,
You were just on one.
we were just on one side. Okay, that's why this is only 1x wide and 1y tall. Okay, the only way we'd have a 2y is if we said take that rectangle and go just as far down. Yeah. Okay, which they don't do. Okay, so don't worry about that. They don't make it that complicated. Does that make sense? Okay. Okay, everybody ready? Okay. Don't read anything other than the word I'm going to highlight. Okay, the word is perimeter. Okay, now let's slide over here. Look at this right here. Now I'm going to draw this again. This was 2x and y. Okay, now if somebody just walked in here and I said, hey, can you tell me something about the perimeter of this? Okay, perimeter is distance around the outside. So Samantha, what would we do?
Would it be 4x plus 2y?
It would be 4x plus 2y, and here's why. If the bottom is 2x, the top is 2x. If the right is 2y, the left is 2y. So then we'd add all those together, so that would be 2x plus y plus y. Is that okay? So the perimeter would be 4x plus 2y. Good there? What do we not like about this? Two variables. So we're going to write everything in terms of x, and this is where, so I'll make this back to the right size. What do we put in place of, what do we put in place of the y? Square root of 4 minus x squared. That's it. Express the perimeter P of the rectangle as a function of x. Have we expressed the perimeter with only x's? Absolutely, there we go. Okay, and then you get to grab your calculator, because once you get here, all you have to do is type it into your calculator, make sure you type it in the right way, and you're in business. So first we're going to do A. So we're going to type in 2x and then the square root and it's a 4 minus x squared, and then we'll close the parens, and that's what we've got right there. So there's the area. Okay, since we're already here, let's save a little bit of time. Let's type this in also. This is going to be 4x plus 2, and then it's going to be square root of 4 minus x squared. Close the parens again. There we go. Now, I only want to graph one at a time. I don't want to graph both of them. Does anybody remember how to do that? How can I turn this one off? Yeah, highlight the equal sign and just hit enter, okay? If the equal sign is not on, it won't graph that, okay? Good? Okay, take a look at this diagram right here. Okay, if you just hit zoom 6 or just graph it in the standard window from -10 to 10, that's usually not going to work very well for these problems, so let's consider this. What's the biggest x can be here? 2, right? What's the smallest x can be? Okay, careful there, because if we pick x on this side, we've already determined what has to happen over here. So the smallest x can be to make a rectangle would be 0. Is that all right? Okay. So when I set up the window, I'm going to start at 0 and I'm only going to go to 2. Okay, now normally we'd be from -10 to 10. So I'm going to leave it like that. So I'm just going to go from 0 to 2 in the x and from -10 to 10. Now, the y coordinate is going to be an area. Is area ever negative? Okay, so we know we're probably not going to find anything down there. I'm going to hit graph. That's kind of a cool shape. Kind of looked like a line to start off with. Okay, and then it kind of dove down. It doesn't look like it gets any higher than 5, and there are definitely no negatives. So here's what I'm going to do. I'm going to go back to this window. That was a good choice for x. I'm going to get rid of the negatives, or sometimes we use the trace. So I'm going to put in -2. That will leave me a little bit below there so I can see the x and y values as we trace. And I'm going to go to 5. It didn't look like it got any higher than 5. Is everybody okay with that? Okay, and let's see what we've got here. That's a pretty darn good graph. Okay, where does it look like the maximum area occurs? Remember, this is x. This is just the width of the, or what the x we chose is. Okay, and this is the y-axis. That's the a-axis. Okay, so where does it look like it is? About right there. About, let's see, if this is 0 and this is 2, about 1.5-ish. Okay. And I'm not sure we did this on the calculator the other day, but we're going to hit, so if you hit calculate, second trace, it'll let you find a maximum, okay? And it's pretty good about things. Can you see why I did the -2, even though the graph doesn't go in the negative? See, I can see all this stuff without covering up the original graph. Okay. So it's really friendly here. It says, what's the left bound? So is this on the left side of where we think the maximum is? It is. So to say yes, we just hit enter. Then it says the right, and you'll notice that it left that little triangle there, that little cursor mark. So all we have to do is make sure we're on the right of where we think the maximum is, and that's enough right there. Hit enter. And then it says guess. You don't have to guess, but I usually like to jump a little bit inside that little interval that we just defined. Hit enter. It works for a second, and it will spit out the answer. It says the maximum is 4. And it occurs at 1.414. Okay? So it says, for what value of x is A the largest? What's the x value that produces the maximum area? Okay? So this is going to be 1.414. That's our answer to that problem right there. Any questions? We're good? Okay. Let's go back here. What am I going to do next? I'm going to do the same thing, but it says do it for the perimeter. So I'm going to go back here. I'm going to turn that one off, and I'm going to turn this one on. What about the window? Should we still use 0 to 2? Yeah, because it's all in terms of x. Whether you're talking about perimeter or area doesn't matter. What's the smallest x can be? 0. And what's the biggest x can be? 2. So we're still in good shape with that. Are we ever going to have a negative perimeter? No, but we should have a little bit negative so we can see the coordinates and that sort of thing. Okay. What about a max? Does a perimeter of 5 sound pretty reasonable? Well, let's check and see. Let's say we're wrong. We'll see pretty quickly because we either won't see the graph at all, okay? But this one goes up, and then, well, it looks like it's completely done here, so let's see what we've got. I clearly need to go a little bit taller, so let's go to, say, 15. Okay, similar type of shape, it kind of dives off at the end, okay? So we'd want to see where, for what value of p or x is p the largest, we'd want to find that right there. Now, do I need to run through the whole max thing? Do you want to see how to do that again, or are you okay? Does anybody want to see that? Just pop your hand up real quick. Okay, so I hit second trace, second calculate. You hit max. I'm on the left, so I'm just going to hit enter, okay, while I'm there. And then I go over here. Now, I could do this. Just type in 2. That'll take you right there. That's a good way to jump back and forth. Notice my cursor's right there. And then I'm going to guess that it's that. It'll spit out the answer here in just a second. Is the answer 8.94 or is the answer 1.788? Okay, it says for what value of x? So it's the 1.788. Okay? All right. Any questions? Sure? Okay. Let's see if we can speed things up a little bit and get this one done. Okay. Okay, don't read the problem. Just if you started, just stop. That's a triangle, right? If that's a right angle, what would I need in order to figure out the area? The base and the height, right? I'd need the height and I'd need the base. Those are the two things I need. Now, without reading the problem, let's just look at the diagram. How far is it from here to here? Correct? How far is it from here to here? X. So this is y, this is x. Haven't even read the problem yet. If you were going to find the area of that, it would be 1/2 the base times the height. What don't we like about this? Two variables. So we're usually going to write it in terms of x, so this is going to be 1/2 x. Now we're going to come back here and we'll say, look, I usually replace the y with what it is in terms of x's, so let's look at this problem. Either in the problem itself or right here, what does y equal? Y equals x cubed. So this is, whoops, the area as a function of x is 1/2 x to the 4th. Well, that's really nice. That looks pretty cool. Okay, now, we didn't even read the problem. What would be really, I wouldn't advise doing that on every single one. I mean, these were pretty typical. They're pretty easy, and we just did a couple problems like it. Okay, but we didn't even read the problem. We looked at the diagram and said, well, gosh, they're probably talking about area. If we quickly scan the problem, we can see that they're talking about area. They did us the favor of diagramming it and everything. We did this. We said, hey, it's just going to be 1/2 base times height. We normally replace the y's with x's and did this. Now let's read the problem, which is what you should do first, and let's see if we did everything correctly. It says we've got to write, yeah.
Where'd you get the x cubed?
Right here in the problem.
Oh.
It says y is equal to x cubed. Questions?
Thanks.
Okay. Right triangle. Did we make the right assumption here? Okay. It was a right triangle. Has one vertex on the graph of x cubed, so there's one right here, so that's what it's describing there. Okay, another at the origin, 0, 0, and a third on the positive axis at 0, y, so we're right there, as shown in the figure. Express the area as a function of x. So we made it pretty simple on ourselves because we could just look at the diagram and say, hey, if they're talking about area, it's got to be this. If they want it as a function of x, then we'll just replace what y is. We'll just put x cubed in its place, and there we go. That's it. That's all you have to do on that problem. Some of these, all they want you to do is come up with a formula. Others, they want you to use the formula to find where the maximum area is or the perimeter or something like that. Does that make sense? Okay, all right. Flip the page over. See if we can do this one, and then we'll finish this up tomorrow. This is enough that you can get started on the assignment, especially the ones that are about area. You can do any of those at this point. Okay, so think your way through that. Yeah.
Do you know if these are, if the problems in the book are as easy as these or not?
Yeah, some of them are they're very, very similar. Okay. I didn't do the hardest one, but I don't know how to do that. Just kidding. Okay. Distance between 2 points. Okay, now did we not just a couple minutes ago remind ourselves of what the formula was? Okay, and we did one with variables and stuff like that. It says, let this be a point on the graph of x squared minus 8. Okay, what shape is that? Okay, now if you look at the graph down here, they did not do us the favor of drawing a picture for us. So let's draw what this looks like. This crosses at -8. Crosses right here, and it goes up. So if I go over 2, I'm going to go up 4, and if I go over 3, I'm going to go up 9, so it's going to look something like this. That's what the graph looks like. And it says this point, xy, is on that graph. So let's put it right here, and let's call it xy. Express the distance d from the point P, that's point P, to the point 0, -1 as a function of x. Okay, so let's see, 0, -1, right here. 0, -1. So we're basically asking ourselves, how far is it from here to here? So how far from 0, -1 to x, y? Have we done a problem like that? Didn't we do one in the starter question? So the distance would be, it would be x2 minus x1, quantity squared, plus y2 minus, right, the minus, then go figure out what the y1 is. That's a -1 quantity squared. Any questions? X squared, that looks nice. Plus, let's clean this up just a little bit. This would be y plus 1 quantity squared, correct? Okay. Somebody tell me what's wrong with this. Two variables. We normally don't like this, do we? So what do we do with it? Yeah. What does y equal in this problem? X squared minus 8. So wherever there's a y, I can put an x squared minus 8, and that will give me a function of x. So this problem is going to be, now I'm going to write d of x. X squared plus, in place of the y, I'm putting x squared minus 8 plus 1 quantity squared. Okay, I've accomplished my goal of getting it all in terms of x's, but let's clean this up just a little bit further. This is going to be x squared plus x squared minus 7 quantity squared. Now, if you want to square this out, collect like terms and all that sort of stuff, be my guest. Do you have to do that? You don't. You could leave it just like this. This is the answer to the first part of the question. Okay, take a good look at this and then I'm going to let you go. What is d if x is 0? Don't say anything out loud. How would you solve that problem? What is d if x is 0? It's asking you to do something. What's it asking you to do? Yeah, wherever there's an x, wherever there's an x, put a 0. So plug in a 0, figure out what the answer is. What's this one telling you to do? Plug in a -1, figure out what the answer is. And then it says graph it. And then it says this last one, for what value of x is d the smallest? Graph it on the calculator and not find the maximum, you'd find the minimum. Have a great day. Correcting 3-4 at the beginning of class tomorrow along with 3-5, so bring them both. Okay?